How y'all doing? We're gonna do chain rule today. Last time my internet wasn't working that good, but this time it should work fine. Some of you already had a question about that. I already answered it about the chain rule, and let's do it again. So the derivative of outside times the derivative of inside. That's what the chain rule is. Let's wait a minute. All right. Oh, okay. Philman, I will chew my food from that. I'm eating less crunchy food today. Oh, maybe it was me unwrapping the bag. Maybe that caused it. You guys suggested it, all this type of food last week. You guys could have picked what's non-making food? Makes noise. Non-sound food. I like mashed potato. All right, let's do it. So I think it was your question, Philman. How to do the derivative of that. So let's go directly to do one of the problem. Y equals 3 times 4 minus x squared to the 5. And what's the derivative of that? And I believe you chose watermelon. I'll pick watermelon next time. I think this was one of your questions, how to do the derivative of that. And I did that in last class. So that was a hard problem, and I didn't expect you to do it without learning these. So let's do the derivative of that. So let's figure out what's the outside. This is the outside, and this is the inside one. Outside, inside. So what's the derivative of outside? It would be 15 times 4 minus x squared, 4. And this is the inside one. And what's the derivative of inside? That would be negative 2x. So if we just simplify it, 30x, 4 minus x to the 4th. Any question? Y'all? All right, let's try this one. All right, find the derivative of that. I should get one of those professional mukbang video microphone that like amplifies the sound like crazy. We'll have our next exam either end of next week or following weeks for early of following week. Let's look at the due dates. All right, let's do it. So here's another way of doing this problem. 9x plus 2, 2 over 3. That makes our life much easier. Now over there, this is the outside one, and this is the inside. So the derivative outside would be 2/3 9x plus 2 minus 1/3, because I got to subtract the 1 from that. And then we times by what's the derivative of inside, which is just 9. If we simplify it, it becomes 6 over 9x plus 2 1/3. Any question? Guys, if you have any homework questions like chain rule, crazy chain rule problem, give them to me, because today all I'm going to do is all chain rule. Chain rule, chain rule, chain rule. So if you have questions, start shooting me right on the question on the chat. So far the chat is good. All right, let's try this one. Let's find the derivative for this. -4. Let's try to find the derivative for that. Any question yet? All right, let's look at it. I'm going to rewrite the problem like that. Now from there, I know this is the outside, and it's easier for me to do the derivative of that. And the derivative inside is just -20. Can we simplify that? Yes, we can. 2 4 will be -8 over 1 minus 20x. All right, no question? All right. Let's try this one. 27x, x minus 3 to the third. Some of you guys are not doing the homework. What's going on? Those of you who are not doing the homework nor taking the quizzes, I'm going to drop you, or I'm going to lock you out. Holy Bible, what is going on? Okay. No, I haven't done that problem yet. All right, so let's do this one. That's a hard one. All right, so we're gonna use first product rule, then the chain rule. So for the product rule, here's your f and g. So h prime equals what? F prime times g plus f times g prime. So 27 times x minus 3 to the third plus 27x times x minus 3 to the third. And we got to do the prime of that. It's the seaweed chips that made me super hyper. All right, am I slowing down? Am I going the right speed? Because you weren't asking a lot of questions, so to me it felt like you guys are understanding everything, so therefore I can speed it up. All right, how's this speed, the one I'm doing? Okay, so now we did the product right over here. This is the part done. Now we got to do this part right over here. I'm going to do this part separately. That's where we use the chain rule. All right. So if I use the chain rule right over here, this is the outside. So 3 times x minus 3 square. And then this is the inside one. That's just 1. So derivative of that would be 3 minus x. So this information will come back over here. All right. Now let me rewrite the problem. X minus 3 to the third plus 27x. And we did that part right over here. 3 times x minus 3 square. Here comes the crazy algebra, kids. What can we factor out to make my life easier? I can factor out 27 from each one. And also I could factor out x minus 3 square. You have this 1 left. 1 left. So if I factor on these out, what do I have left? X minus 3 plus, from here I'm left with 3x. That's it. And if I simplify a little bit more, x plus this is 4x minus 3. Voila, it's done. All right, any other question yet? Should I redo the problem that last class? When I tried to do it, we had a terrible internet and the problem was so difficult we got stuck. Let me bring that down. I don't know if most of you came or not. All right, this one. It's like chain rule on steroids. Question was, wait, is that the right one? Let me make sure. Yeah, that's the one. Find double derivative of that. Okay. So no one is saying my pace is fast, so I'm gonna go. If I'm going fast, shoot me a text, and I'll slow down. So again, product rule first, and then chain rule. All right. So if I do the product rule right over here, I get 1 times 3x plus 5 to the 5 plus x times 3x plus 5 to the 5, and that's, I gotta do the derivative of this part right over here. And for that, we use the chain rule, and gives me 5 times 3x plus 5 to the 4th times what the derivative of inside would be 3. So if I just simplify it, I get 15 times 3x plus 5 to the 4th. And I'm going to put that information back here. 3x plus 5 to the 5 plus x times 15 times 3x plus 5 to the 4th. This one, that's a really cute problem, actually. That's a cute problem. Okay, first of all, like, I don't know if I'm calling your name he or she, it's throwing me off. Sometimes I think it's a girl name, sometimes I think it's a guy name. I don't know what it is. So, is there any word for, like, if you don't know the sexes to it? I'll just call you guys it. I'll call you guys it. So, all right. This is a cute problem. Now, let's simplify it again. What can I factor out? I could factor out this 4th, and over here I could go up to 4 and then 1 left. So therefore I get 3x plus 5 to the 4th. I've left is 3x plus 5 plus 15x. Oh, okay. All right, Philman. All right. You that becomes redundant, Philman. All right. There's a name is Alotad. I don't know what is that. Can you guys go change and write it a proper name? All right, let's simplify it a little bit more. 3x plus 5 to the 4th. This becomes 18x plus 5. Now, this is the first derivative. How do we do the second derivative? Again, we got to do the product rule. So 3x plus 5 to the 4th. Derivative of that, 18x plus 5 plus 3x plus 5 to the 4th times 18. Derivative of that inside. All right. Let's do the derivative of this part. 3x plus 5 to the 4th. Derivative of that. Again, derivative of outside, you get 4 inside the parentheses, 3x plus 5. And then it just 1 reduces that. And then what's the derivative of inside? 3. So we get 12, 3x plus 5 to the 3rd. So let's use that information to plug it in. 3x plus 5 to the 3rd. 18x plus 5 plus 3x plus 5 to the 4, 18. All right, no question yet? All right, children. So what can I factor out? Did I say I'm going to give you a quiz today? Oh, I could factor some part of this out. So if I factor out 6, 3x plus 5 to the 3rd, I've left is 2, 18x plus 5. And over here, 3, 3x plus 5 adds to the 1. All right, let's simplify it. 3x plus 5 to the 3rd. You get 36 x plus 10 plus 9x plus 15. 630x plus 5 to the third. You get 45x plus 25. Woo. One or two steps. I could do it in my head, but you guys were complaining how like I'm taking forever, like I'm going too fast, like zooming. Like as you do this problem more and more, you will see it. You could get this done in fewer steps. If we had this in-person class on exam, I have to for you to get all the credit, you have to show all these steps. All right, let's do this one. Oh, that's a good one. Sine of cosine of 9 theta. Okay, try this. Just happen. Oh, it's 9 theta, not 90. 9 theta. Okay, so this is a chain rule within a chain rule. So the derivative of outside, which is this one, derivative of sine is what? Cosine of 9 theta. So we did the first outside. The next one is, now we go derivative of inside, which is this. What's the derivative of cosine? Again, it's a chain rule. It will be negative sine of 9 theta. And then the last one inside that, derivative of that would be 9. Let's clean it up, make it nice. Negative 9 sine of 9 theta, cosine of 9 theta. Did that help? Okay, let's try this one. H of theta equals sine of theta over. All right, let's try that. That's a hard one. Can you use the different brackets since C looks like better? Or I should write C like that. I'll write my C like that. Okay, try this one. Okay. So this is chain rule inside a quotient rule. So let's look at it. First thing first, the derivative of that would be, it's super easy, cosine of theta. That's easy. Now we got to do the derivative of this inside. What's the derivative of that? Let's do it. Let's use the quotient rule. 1 theta minus 4 minus theta. Oh, Lord. Let me rewrite this way. Theta minus 4 to the 1/2. Boom. That makes my life so much easier. The derivative of that would be chain rule. Negative 1/2. Okay. Over theta minus 4. If you square that, square root of square is just theta minus 4. All right. Let's simplify it and clean it up. Theta minus 4. This gives you theta over 2 theta minus 4. Lord, look at that. We have all this fraction within a fraction. We gotta get the common denominator, multiply everything by 2 theta minus 4, 2 theta, square root of theta minus 4. So if I do that, it's your regular algebra stuff. It becomes 2 theta minus 4 minus theta minus 4. Now, this goes down fraction over fraction. You get 2 theta minus 8 minus theta over 2 theta minus 4, 3/2. And this becomes theta minus 8 over 2 theta minus 4, 3/2. Oh, Lord, look at that. Copy. So you get cosine of theta, square root of theta minus 4, and we just did the derivative of that. Voila. And that's your final answer. Whew, that was a hard problem. All right, I'm going to start the implicit differentiation lecture. Let me see, when is the implicit view? How about ask me questions about chain rule before I start doing the implicit, because this is a really hard one. Let me see, when is the implicit differentiation due? Is 3, 9, 10. Oh, you still have time. 9, 10. You still have time. Okay. All right, ask your question. Do you want me to do the implicit differential today? We have another class for it. Or you want me to ask question about the chain rule? If you have hard chain rule problems, ask me. You guys are quiet. I don't know what that means. Can you do one with the weird E? Give me a question. I don't know. Let me open. Do I have a book? Do I have a music book? Let me see. Let me try to open one. Okay, let's do a hard one. Good question. All right, let's do this one. E to the... Oh, I didn't even teach you that because it has to deal with implicit differentiation. That's why. Should I teach you that? Okay. All right. The rule for E is if you have e to the x, the derivative of e to the x is just e to the x. Now comes the chain rule. If it's e to the, let's say, u, then y prime would be e to the u times u prime. Okay? So that's the chain rule right over here. So let's look at it a problem. Y equals e to the 2x over 3. So what would be the derivative of that? It would be e to the 2x over 3 times 2x over 3, the derivative of that. And the derivative of that would be just 2/3. If we simplify it, you just get 2 over 3, e to the 2x over 3. Now, are you going to get this type of question on the exam? You wish. Actually, I'm gonna make the next exam more like word problem because I'm hearing like people are using all these online tools to get the answers. So I'm gonna make the exam all word problem. So you can't cheat. All right. So let's look at another hard problem. Y equals e to the 4 square root of x plus x squared. Ooh, that's a hard one. All right. Y prime. Super easy. E to the 4. That was easy. Now what's the derivative of that? Oh, that still is easy. You get 1/2 2 square root of x plus 2x. E to the 4 square root of x plus x squared. Yeah, still easy. All right, let's see. I've taught you guys the derivative of all the trig functions, right? Okay, let's do this one. It's not a trig one. Can you provide an example of word problems? Oh yeah, trust me, we're gonna do a lot of word problems. By that time, you guys will hate me. So if you still don't hate me about me eating food during the lecture, or making food noises, oh, you're gonna hate me by then. It's like you're gonna compare me with Darth Vader. In fact, you would feel that Darth Vader has mercy, whereas I don't. All right, kids. Let's try this one. They're cube. I'll give you a couple minutes. Do you want me to do this problem or give you the answer? Decide. Are you guys excited about the $1,400 check you guys are going to get from Biden? What are you kids going to do with that $1,400? Of course I'm going to do it. That was a trick. like not rhetorical question. That was a question to annoy you guys. All right, let's look at it. So it's gonna be chain rule within a quotient rule and so on. Right away, the easiest part would be t square, t cube minus 4t square. I'm going to buy frogs to eat them? For what? I mean, they sell frogs at Smith. Frog's leg. And we do the derivative of inside. No, I want the whole frogs. Again, to eat frogs. Oh, frogs are cool. Oh, you weirdo. All right. What is this? Who had a pet for pet frog in Harry Potter? They don't pay taxes. Harry Potter. Who had frog? Let's Google it. Who had a Trevor? Oh, that was Neville's pet toad. There you go. Yeah. Yes, Neville. Dude, that guy was such a dork. And if you have seen his latest pictures, that guy looks the most awesome look out of all of them. If you have seen some of his latest picture. All right, let's do the derivative of this. T square all right, so let's do the quotient rule over here. 2t times t cubed minus 4t minus t square. A derivative of 3t square minus 4. And at the bottom would be t cubed minus 4t. Okay? All right. Let's clean this up. Let's make it look nice. Yeah, we'll distribute it out. T fourth minus 8t square minus 3t fourth plus 4t square over t cubed. Oh, forgot to square that. Minus 4t square. We get this is fourth. Is it windy outside? It's like I'm hearing like crazy wind, like people are killing each other. T fourth minus 8t square over t cubed minus 4t square. Okay, so that's the crazy derivative of that. Hopefully I got that right. Copy. I don't need to write it again. I could just paste that sucker. Wait, what's missing? Yeah. And then 3. T to the fourth over t3 4t square. Ooh, I can make the problem prettier. So 3t to the fourth minus t to the fourth minus 8t square over t cubed minus 4t to the fourth. Oh, voila. Any question? All right, kid. Let's try another problem. How big is your toad? Is it gonna be? Is it gonna be like, wow, like small toads, big toads? Are you gonna use it to feed your other animals, or just do you want to use it as pet? All right, let's try this one. Y equals sine x squared e to the x. All right, let's do this. What's the derivative of that? You have sine of x squared times e to the x. What's the derivative of that? Let's not hate on the government. All right, let's do this. All right, ask me a question. If not, we're going to end it right after this one. And then if you have a personal question, I'm here to answer your personal question. So derivative outside would be cosine of x squared e to the x, and then we do the derivative of inside. And what's the derivative of inside? We do product rule. 2x e to the x plus x squared e to the x. Cosine of x squared e to the x and then I get 2x e to the x plus x squared e to the x. We could leave it at like that, but maybe we could factor something out. What? X squared e to the x, and you get x squared plus 2x. You could do that too, but they are still all the same. All right. Let me hear some questions. Any questions yet? No. All right, I'm gonna end the lecture over here, and then I'm gonna be here if you have any question.